Welcome back to the 7th hour math lab at Lewis and Clark. I'm Mr. Monty. We're going to start a series of 8 little videos to get you ready for the Unit A assessment. The first one will relate to practice 001. So, whether you get it off the website, montymath.com, or if you come to the math lab in the after school, you can pick up practice 001 for Unit 8A, and it will relate back to this video. This is a skill that you will need to be successful on the unit final. Exponentials. Let's start out with the basic form, y equals a b to the x. A is the starting value when x is 0. B, that's the growth or decay constant. We have our data table. Let's get started. First thing we want to do is try to find the starting value when x is 0. Right there. So we're going to have a equals 2. Halfway home. Now, to find the growth or decay constant, we take the values and work backwards, dividing one by the other. 2 divided by 1 gives us a 2. 4 divided by 2 gives us a 2. 8 divided by 4 gives us a 2. And 16 divided by 8 also gives us a 2. Notice that we have a constant. It's the same value each time. That tells us we do have a geometric sequence. Times by 2, times by 2, times by 2, times by 2. When we see that, we know we have a geometric sequence, and we can find the b value, which is 2. Now, let's put it all together. Y equals 2 times the constant growth factor, in this case, to the exponent of x. This function describes this set of data. Growth, if we were to graph it, the most important value is the y-intercept, 0, a, the starting value. Now let's change this up one time and give us a different set of data. So that we can see an example of decay. First thing we'll do is we want to find the starting value when x is 0. In this case, the starting value when x is 0 is 8. Second thing we're going to want to do, we want to find the constant. Make sure it's a geometric sequence and that we do have the constant growth or decay, and in this case, decreasing decay. Again, working backwards, we divide. 8 divided by 16, 1/2. 4 divided by 8, 1/2. 2 divided by 4, 1/2. And the last one, 1 divided by 2 is 1/2. Because they were all the same, we know that we do have a geometric sequence because we have the constant decay rate. Good job. So let's write this out. Y equals the starting value, 8. It's important on that starting value that we look for when x is 0. The growth rate, 1/2, to our exponent of x. The last thing we want to do is actually look at it on a table. If we were to actually graph these points, we'll have 0, 8, and a function that looks something like that. So just remember, we're going to have a series of 8 tutorials leading up to the unit exam on exponentials. And this was practice 001. Stop by the math lab to get your practice sheet.